Hi dear students, in the last class we discussed the wave equation for the electric and magnetic field in vacuum. As a continuation of that previous discussion, today we talk about the monochromatic plane waves in vacuum. Then what is the meaning of the monochromatic? Monochromatic means having the single frequency means single wavelength. Okay. In the electromagnetic spectrum, that is simply we call EM waves, they are from the radio wave to the gamma rays. In short, we will call it as a Ramelix gamma. Ramelix means here, this is a radio wave, microwave, infrared, light, ultraviolet, X-ray, gamma ray. I have written this code in the decreasing order of the wavelength. It is here radio wave have the larger wavelength and the gamma ray have shorter wavelength. That is here the frequency, that is here the lambda is larger, lambda is smaller. Frequency here, frequency is smaller, frequency is larger, because f is equal to c by lambda. Here the radio wave has a particular value of the wavelength, and that is different from that of the microwave, which means each wave in the spectrum has its own wavelength. That means the radio wave is a monochromatic wave. Similarly, microwave is another monochromatic wave. Infrared wave is another monochromatic wave. No two waves in the spectrum have the same frequency or same wavelength. As the name mentioned, that is a electromagnetic wave. That is, this wave consists of both electric and magnetic field. Then if I draw the axis of the propagation, and this is Z, X, this is Y, it consists of both the electric and magnetic field. Then along the X direction, I consider this is the electric field component. This is the electric field component. Now the magnetic field component. Like it is parallel to the Y direction. This is a magnetic field component B. And this wave propagates along the Z direction. This is a speed of the wave, or this is a propagation direction, is around this Z direction. Therefore, both the E and the B are perpendicular to the direction of the propagation. Therefore, EM wave is the transverse wave. EM wave is transverse in nature. That is, E and B are perpendicular to the direction of propagation. Because the electric field is along the X direction and magnetic field is along the Y direction. The direction of propagation is along Z. Now let us define what is a plane wave. That is, the electromagnetic wave confined to move in a single direction, that is along z direction in the figure, and the E and B vectors both lie in a plane, that is the figure, the both lie in the xy plane. That plane is perpendicular to the direction of the propagation. Then that wave is called a plane wave. I will draw the figure of the plane wave here for the better explanation. In this figure, it is clear that the electromagnetic wave that is propagated along z direction, that is the velocity is along z direction, and the electric and magnetic field vectors that lie in the x and y plane, that is perpendicular to the direction of the propagation. അപ്പോൾ ഇവിടെ electromagnetic wave confined to move in a single direction, and the electric and magnetic field vectors both lie in the x y plane, that is perpendicular to the direction of the propagation. Then this is called a plane wave. Okay, let me write the definition here. Okay, that is the definition of the electromagnetic plane wave. That is a EM wave confined to move in a single direction, that is we have discussed along the z direction, and electric and magnetic field vectors both lie in a plane, that is xy plane in the figure. That plane is perpendicular to the direction of propagation. Then that electromagnetic wave is called an electromagnetic plane wave. Okay, now let us proceed. In the last class, we have discussed the wave equation for the EM wave in free space. That is, in free space, charge density will be 0 and the current density will also be 0. Therefore, the wave equation that we have written is del square E is equal to 1 by c square dou square E by dot E square, where c is equal to 1 by root of mu 0 epsilon 0. Okay, since the wave propagation is along z direction, this can be written as dou square E by dou z square is equal to 1 by c square dou square E by dot T square. Okay. Similarly, for magnetic field, dou square B by dou z square is equal to 1 by c square dou square E by dot T square. Why this is along z square? Because both E and B, both the electric and magnetic field, are propagating along this direction, z direction. That is why in this figure or in this picture, both the electric and magnetic field all are propagating along z direction. That is why we have taken this as a dou square E by dou z square. Here we can write the plane wave propagate in the z direction, then electric and magnetic field are independent of x and y. If you see this picture, that is very clear. That is both the electric and magnetic field E and B lies in this xy plane, and they are independent of the propagation direction, that is z. If so, what we will write? The x component, the electric field is along the x direction and magnetic field is along the y direction. This is the direction of B, and this is the direction of electric field, this is the direction of the magnetic field. Therefore, we can write Ex because this is x direction. Dou Ex by dou x will be 0, and dou Ey dou y will be 0, dou Bx by dou x will be 0, dou By by dou y will be 0. The electric and magnetic field components, or the magnitude of the electric and magnetic field, may have the change with respect to z direction only, because the wave is propagating along z direction. That's why we have written here the plane wave propagate in the z direction, then electric and magnetic field are independent of x and y. Therefore, I can write here dou Ex by dou x is equal to 0, dou Ey by dou y is equal to 0, dou Bx by dou x is equal to 0, dou Vy by dou y is equal to 0. And also all other component dou Ex by dou y is also 0, because electric field is along x direction. There is no change with respect to the y direction. Then if I write the wave equation, well, how can I write the wave equation? Because electric field is along x direction, therefore dou square Ex by dou z square, that is equal to 1 by c square dou square Ex by dou t square. Then what will be the solution of this wave equation? The solution can be written as Ex is equal to E0 sine kz minus omega t. Since the wave is along the x direction, here this should be x cap. This is the solution of this wave equation. Okay, that is for, if I write the full, that is it will be Ex zt. The electric field component along the x direction propagate along the z direction. Direction of propagation is along positive z in this picture. Okay, that is, if you refer the picture 1, the electric field is along x direction, magnetic field is along y direction. Propagation is along this z direction. Now, if the electric field is given, that is, electric field is having the x component and it is propagating along z direction, then what will be the magnetic field? What will be the magnetic field? If Ex is the electric field component, then what will be the magnetic field? For this, we can use the Faraday's law. Use Faraday's law. The Faraday's law is del cross E is equal to minus dou By dou t. Here the electric field component is along x direction. Okay. That is, this E is having the component along the x direction only. Therefore, to find out the magnetic field, we have did a lot of problem to find the curl of a vector. We can do the same here also. That is, we have divergence in 3 dimensions, that is x cap, y cap, z cap, and the x direction del operator has dou by dou x, y direction dou by dou y, dou by dou z, and we have the electric field component only along the x direction. We have the electric field component only along the x direction. You see here, the electric field is along x direction. That is why we have written here, while writing the curl of E, Ex, y component 0, z component is 0. The right hand side is minus dou B by dou t. For the moment, I am omitting this vector notation. Okay, then what will be the result? X cap dou y is 0 minus this 0 minus y cap 0 minus dou ex by dou z plus z cap 0 minus dou ex by dou y. The right hand side as it is minus dou b by dou t. Now, if you check this equation, the electric field component varies with z. Therefore, dou ex by dou z cannot be 0. What about dou ex by dou y? Variation of the electric component x with respect to y. That is somewhere else we have written. Yes, here dou ex by dou y is equal to 0. Therefore, this quantity goes to 0. The remaining thing is y cap dou ex by dou z is equal to minus dou b by dou t. Okay, then what is ex? Ex we have this one ex. Then if I find dou ex by dou z, because here we need to find the dou ex by dou z. The dou ex by dou z, if I differentiate this equation with respect to z, then this will be E0 k cos kz minus omega t. Then I can write here that is y cap dou ex by dou z means E0 k cos kz minus omega t is equal to minus dou b by dou t. Then it is very clear, to get the magnetic field, just integrate this equation. If you do the integration, that will be B is equal to y cap is still there. Integration of this term with respect to t is E0 k by omega with a minus sign, then sine kz minus omega t. Integration of cos is sine. Here you have one minus also. That minus is here. Then these two minus will cancel. Plus the answer is this is equal to E0 by omega. That is k E0 by omega sine kz minus omega t direction on y. See here this magnetic field, the magnetic field B can be written as k E0 by omega, this is a small k, sine kz minus omega t y cap. As we expected, the magnetic field should be L on y direction. We expected here, that is electric field is along the x direction. Here the propagation is along z direction. Then since it is a transverse wave, that is both the electric and magnetic field are perpendicular to the propagation direction, that the magnetic field should be along y direction, by. That is, once again it is confirmed, this by, this is nothing but the magnetic field along y direction is nothing but this by. If I write this term, that is B0, therefore the expression can be written in this way: by traveling along zt, z direction, that is equal to B0 sine kz minus omega t by k, where this B0 is equal to k by k E0 by omega. This is the amplitude of the magnetic field. What is that amplitude? The amplitude is B0 is equal to k by omega E0. This term you might have seen somewhere else. That is, velocity of a wave is defined as omega by k, or 1 by v can be written as k by omega. In the case of an EM wave, for an EM wave, the velocity is nothing but velocity of light. It is EM wave in free space or vacuum. Okay. Therefore, this can be written as 1 by c is equal to k by omega. Then I can rewrite this equation B0 as, instead of k by omega, I substitute 1 by c into E0. It is nothing but E0 by c. Now, if you take the ratio is ratio of E0 by B0. It is nothing but C is equal to, you have already learned, that is 1 by root of mu 0 epsilon 0. Then I will do another substitution here. That is, instead of B0, I make a small substitution. That is, you know that total magnetic field, magnetic flux density B is equal to mu 0 H plus M. If magnetization M is 0, then that B is equal to mu 0 H. In this equation you might have learned in the +2 class. Otherwise, once again we will meet the same equation in the forthcoming lectures. B0 can be replaced by mu 0 H0. Therefore, this will be E0 by mu 0 H0, that is equal to 1 by root of mu 0 epsilon 0. From this you can write, that is E0 by H0, that is equal to mu 0 by root of mu 0 epsilon 0. It is nothing but mu 0 by epsilon 0. If you substitute the value of mu 0, that is 4 pi into 10 power minus 7. Epsilon 0 is 8.85 into 10 power minus 12. Then if you do the calculation, this will be 377. Now, what will be the unit of this E0 by H0? So what is the unit of the 337? For this, I would like to draw your attention to this area. That is, we have E0 by H0. Then what is the unit of E0? We know the potential difference V is equal to E into D. That is, E is equal to V by D. Unit of voltage is volt, and unit of the D is the meter. Okay, volt per meter is the unit. H0, you know the magnetic field due to a wire, mu 0 I by 2 pi r, or B is equal proportional to I by, or B by mu 0 is proportional to I by r. This B by mu 0 is nothing but, just now we have seen, is nothing but H. The 0 is proportional to I by r. The unit of I is ampere. Unit of radius is meter. Therefore, here I have the two quantity. Unit of electric field is volt per meter. Unit of magnetizing field is ampere per meter. Then substitute these two here. This will be volt per meter divided by ampere per meter. Okay, things are very easy. E0 by H0 is equal to, these two will be cancelled out. and this will be volt per ampere. What is a volt per ampere? Again, come to this case, that is Ohm's law. Voltage V is equal to I into R. Volt per voltage divided by current is resistance. That is, this is nothing but volt per ampere. That is, resistance is ohm. Resistance in the unit ohm. അപ്പോൾ നമുക്കിങ്ങനെ എഴുതിക്കൂടെ വോൾട്ട് പെർ ആംപിയർ എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ ദാറ്റ് ഈസ് റെസിസ്റ്റൻസ് ഓം. ദാറ്റ് ഈസ് എ യൂണിറ്റ് ഓഫ് E0 by H0 എന്ന് പറഞ്ഞാൽ റെസിസ്റ്റൻസ് ആണ്. 337 അല്ലേ, നമുക്ക് ഇവിടെ കൊടുക്കാൻ പറ്റും. Here also we have the E0 by H0. This unit is ohm. That is, this value has a very interesting significance. That is, it is E0 by H0 is 337 ohm. That is, E0 by H0 is the resistance of the vacuum or resistance of the free space. This the E0 H0 has the dimension of the resistance. For this is the resistance of free space. Here, instead of representing the electric and magnetic field in this sine form, the sinusoidal function, we are interested in representing them in the electric and magnetic field in terms of the exponential form. കുറച്ചുകൂടെ കാൽക്കുലേഷനൊക്കെ കുറച്ചുകൂടെ ഈസി ആക്കാൻ എളുപ്പം നമ്മൾ മുമ്പ് പഠിച്ചിട്ടുണ്ട് കോംപ്ലക്സ് നൊട്ടേഷനിൽ റെപ്രസെൻ്റ് ചെയ്യുന്നതാണ്. അതുകൊണ്ട് നമുക്കിതിനെ ഒന്ന് മാറ്റി എഴുതാം. ദാറ്റ് ഈസ് we are interested in representing electric and magnetic field in the following form. Okay, what is that form? Electric field, complex amplitude, propagating along z direction, that is E0 complex amplitude, e power I kz minus omega t. We have considered this electric field is propagating. Electric field is oriented along x direction. That is, one can say the electric field is polarized along x direction. Then magnetic field component, that was propagating along z direction, can be written as B0 complex amplitude e power I kz minus omega t. This was along y direction. This magnetic field we have written in terms of the electric field, that is E0 by C. Just now we have seen the relation connecting B0 and E0 equal into e power I kz minus omega t y cap. In this way also you can represent your magnetic field. This electric and magnetic field propagating along the z direction, that I will show you the picture, that will be more clear to you. See this picture. Here it is clear that the electric field is along the x direction and the magnetic field is along this y direction. The amplitude of the magnetic field is E0 by C, and usually in the case of an electromagnetic wave, that is said to be polarized in terms of the electric field. Electric field ഏത് ഡയറക്ഷനിലേക്കാണോ ഉള്ളത്, that electric field is along the x direction. Therefore, this electromagnetic wave is polarized along the x direction. ഇപ്പോഴും നമ്മളെ ഒരു ഇലക്ട്രോമാഗ്നറ്റിക് വേവ് പോളറൈസ് ചെയ്തിരിക്കുന്നത് ഏത് ഡയറക്ഷനിലാണെന്ന് ചോദിച്ചു കഴിഞ്ഞാൽ നമ്മൾ ഇലക്ട്രിക് ഫീൽഡിൻ്റെ ഡയറക്ഷൻ നോക്കിയിട്ടാണ് പറയാം. Okay, that is the electric field is along the x direction. Therefore, the EM wave is a polarized along the x direction. Okay. And the propagation is along the z direction. This is a real representation of the propagation of the electromagnetic wave, which has electric field along the x direction and magnetic field along the y direction. Okay, that is represented mathematically by these equations. Okay, fine. Now generally how we can write that if somebody has given the propagation direction and somebody has given the electric field direction is around x, then if you are asked to find magnetic field on which direction, we have to generalize a formula to find the B if all these informations are given. That is, for that, one thing you should remember, the kz, how did you get this kz? The k, wave vector k can be written as kx, x cap plus ky, y cap plus kz, z cap. Then if the wave is propagating along z direction, then k dot z, that will be kz z. Okay. If the wave propagating along z direction means z can be written as z cap. That is why we have written kz z. Fine. This here, since the kz is, if the wave is propagating along the z direction, it is understood that kz is nothing but k along z direction. Simply we will write kz. Let us come back to this one. In finding out the magnetic field, if propagation direction and electric field directions are given, we have x, y, z. That is, x cross y is z, z cross y is x, cyclic order. We have the propagation direction, that is along z. Okay. Cross, if the electric field direction is given, that is x cap, then z cross x, that is the cyclic order, therefore this is positive y. Now if you compare these equations, this electric field equation and this magnetic field equation, then if the propagation direction is z is given, if you are asked to find out the magnetic field, what we have to do is, this z can be taken as a propagation direction, therefore I can write k. Then if the electric field is propagating along the x instead of x, if I write this is a generally n direction, then this will be n, and a k cross n result in the direction of the magnetic field, that is a y in the particular case. For example, I will write in the general way. If the electric field is propagating along y direction, the propagation direction is z. If you are asked to find out the magnetic field, it is very clear that the z direction is the k vector, then k cross y, that is z cross y. Z cross y means this one, z cross y, that will be minus x direction. Therefore your magnetic field will be along minus x direction. This answer. That is, if I generalize the equation, this equation, that is, if the electric field is an arbitrary direction, is propagating along any propagating along any direction, which means here I take it as generally r, then E0 e power I k dot r minus omega t. This electric field is polarized along n direction, or the electric field is directed along n direction. Instead of x or y, we have taken as a n direction. Then magnetic field can be written as BRT, that is 1 by c into E0 power, according to this expression, E0 e power I k dot r minus omega t. Now, what is this y? This y is the result of this z cross x. Z is the propagation direction ആണല്ലോ. Propagation direction നമ്മൾക്ക് ഇവിടെ k എടുക്കാം, because k dot r എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ ആറിൻ്റെ ഡയറക്ഷനിലായിരിക്കും നമ്മുടെ പ്രൊപ്പഗേഷൻ്റെ ഡയറക്ഷൻ ഉണ്ടാവുക. അതുകൊണ്ട് നമുക്കിതിനെ k എന്നെടുക്കാം, k ക്രോസ് n. ഇവിടെയുള്ള ഈ y കിട്ടിയിരിക്കുന്നത് z ക്രോസ് x ആണ്. ഇവിടെ എക്സിൻ്റെ സ്ഥാനത്ത് നമ്മൾ എടുത്തിട്ടുള്ളത് n. ഇതിവിടെ സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്തു. ഓക്കെ, അതായത് പ്രൊപ്പഗേഷൻ ഡയറക്ഷൻ്റെ എന്ത് z ഡയറക്ഷൻ ആണെങ്കിൽ ഇവിടെ z വരും, പ്രൊപ്പഗേഷൻ ഡയറക്ഷൻ x ആണെങ്കിൽ ഇവിടെ x വരും. ജനറലി k ക്യാപ്പ് എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ പ്രൊപ്പഗേഷൻ്റെ ഡയറക്ഷൻ്റെ ആ വെക്റ്റർ, അതാണ് നമ്മുടെ k ക്യാപ്പ്. k ക്രോസ് n, ഈ k ക്രോസ് n ആണ് നമ്മുടെ എന്ത് y വരുന്നത്. ഇപ്പം ഞാനിവിടെ ശരിക്കും y ക്യാപ്പ് എന്ന് എഴുതണം ഇവിടെ x ആണെങ്കിൽ, പക്ഷെ അതിന് ജനറലായിട്ട് ഈ y ക്യാപ്പ് കിട്ടിയത് എങ്ങനെയാണെന്ന് ചോദിച്ചു കഴിഞ്ഞാൽ ദാറ്റ് ഈസ് k ക്രോസ് n. അതുകൊണ്ട് ഞാനിവിടെ നേരെ ഈ k ക്രോസ് n ഇങ്ങോട്ടേക്ക് എഴുതാൻ പോകും. ദാറ്റ് ഈസ് k ക്രോസ് n, പ്രൊപ്പഗേഷൻ ഡയറക്ഷൻ വെക്റ്ററിൻ്റെ ക്രോസ് ഇൻറ്റു ഇലക്ട്രിക് ഫീൽഡിൻ്റെ ഡയറക്ഷൻ. ഈ ബ്രാക്കറ്റ് ഒന്ന് ഞാനൊന്ന് ഓപ്പൺ ചെയ്ത് എഴുതിയത് എങ്ങനെ വരും? BRT എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ 1 by c k ക്രോസ് ഞാൻ ആദ്യം ഇങ്ങോട്ട് എഴുതി, ക്രോസ് E0 e പവർ I k dot r മൈനസ് ഒമേഗ ടി. പിന്നെന്താ ഇവിടെ ഉള്ളത്? n ക്യാപ് അല്ലേ? ഞാനൊന്നും ചെയ്തത് മാത്രമേ ഉള്ളൂ, ഈ ടേമിനെ ഇതിൻ്റെ കൂടെ ഇങ്ങോട്ട് എഴുതി, കെനെ ഞാൻ ആദ്യമേ ഇവിടേക്ക് പുറത്തേക്ക് കൊണ്ടുവന്നു, അതാണ് ഈ കെ. ഇത് നമുക്ക് എന്ത് വരും? ഈ ടേം നോക്കും നിങ്ങൾ. ഈ ടേം എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ നമ്മുടെ ഈ ഇലക്ട്രിക് ഫീൽഡ് അല്ലേ ശരിക്കും ഈ ടേം ഇവിടെ എഴുതിയിരിക്കുന്നതാ, ഈ എക്സ്പ്രഷൻ അല്ലേ? നമുക്കിതിനെ ഇങ്ങനെ എഴുതിക്കൂടെ? ഇ ആർ ടി എന്ന് എഴുതിക്കൂടെ? ദാറ്റ് ഈസ് 1 by c k ക്രോസ് ഇ ആർ ടി, ദാറ്റ് ഈസ് BRT. ഇങ്ങനെ ഈ ജനറൽ ഇക്വേഷൻ നമ്മൾ ഓർത്തു വെച്ചാൽ ഇലക്ട്രിക് ഫീൽഡ് തന്നിട്ട് മാഗ്നറ്റിക് ഫീൽഡ് കണ്ടുപിടിക്കാൻ പറഞ്ഞു കഴിഞ്ഞാൽ ഈസി ആയിട്ട് ചെയ്യാൻ പറ്റും. ഇത് ജാവയിലെ ഒരു ഷുവർ ക്വസ്റ്റ്യൻ ആണ്. കാരണം എപ്പോഴും ഒരു ഇലക്ട്രിക് ഫീൽഡ് തന്നിട്ട് മാഗ്നറ്റിക് ഫീൽഡ് ചോദിക്കാറുണ്ട്. ഓക്കെ, ഇതിനെ നമ്മൾ വേണമെങ്കിൽ കുറച്ചുകൂടെ സിംപ്ലിഫൈ ചെയ്തിട്ട് ഈ ആർ ടി എന്ന് എഴുതാം, അല്ലെങ്കിൽ നമുക്ക് രണ്ട് സ്ഥലത്തും പെട്ടെന്ന് ഓർത്ത് വെക്കാൻ വേണ്ടിയിട്ട് B is equal to 1 by c k cross E എന്നെഴുതാം.